Is another example for review. This is part of Class 8, but also will be in the exam review section. We have a Mohr circle. I believe this is a problem out of Philpott. You can see that we have compression on both sides of this element. And we have a shear of 45.6. We want to find all three principal stresses and the absolute maximum shear stress. And as part of this, we want to draw and completely label a Mohr circle. All right, so let's see. I will do the process all the way through here. So I have some engineering paper out. And maybe I want to go ahead and write down, summarize what the problem is going to be here. I have my stresses, compression on all sides there. And we have 117.5. And these are megapascals. I don't know why we didn't pick a nice even number. 96.3 megapascals. And here we have our shear, and that's a tau. Oh, I don't know why I'm putting a tau in there. Doesn't need it. We just put values. 45.6 megapascals. All right, so here's so these are the skills that we're trying to demonstrate that we know how to do. Mohr circle, very important thing. Let's see. Come on, come on. What's up with you? Document camera, have you been used too much? Is that what your problem is? Shouldn't speak to the document camera. So one of the challenges here when you're getting a piece of graph paper is to try to figure out how we're going to divide it up, right? And use it to its maximum. What increments are we going to do? Well, it looks like we have like 120 is about the largest that we have right there. So let's ramp that up and let's see, can we go, in terms of the width is really the thing that we're probably going to be limited to. Come on, this thing's a pain in the ass. I think it's just that this grid without having something else to focus on. All right. So I am going to go ahead and go by 20s would be too much, right? So if you go 20, 40, 60, 80, yes, that'd be too much. So I think I'm going to go by 10s or by 5s. I guess I think that's what we're saying. Right? Each one of these little squares is going to be 5. And I know it's all compression, so my primary axis, I'm going to make it over to here. And I'm going to guess that I can go this one right to there. Stick it in the middle of the page. And I'll say 10, 20, 30, 40. And so that makes this 50, 60, 70, 80, 100, 110, 120, 130, right? So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Okay, so I think maybe I lost count at some point, right? So it's good that I counted again. There's your 130, and hopefully we won't need to 140. All right, so I really did a good job of picking out these things, making this as large as possible, right? So here you go, here's our 10, 20, 30, 40, 50, 60. Hopefully we won't need more than that. Oh, stupid thing. Come on. Focus. All right, so let's plot out our first point first. So we have 117.5. Right, it's going to be furthest out over here. So here's Here's 115, so it's going to be somewhere like right in there, right? So I'll make a little mark right there. And it's going counterclockwise, so it's going to be in the lower thing, and it's going to be at 45.6. So here you go. There's our 10, 20, 30, 40, 50. Let's extend this thing down. 60, so what did I say? Negative 10, 20, 30, negative 40, negative 50, negative 60, and we have 45.6. My mouse pad's in the way of my pad here. All right. So that would be, here's like 45. So it's going to be pretty darn close to that right there. Right? Not much more off. Here's our 120, so like right there. And let's just remind ourselves by writing the thing down. 117.5 and negative 45.6. All right, so the other face is going to be negative 96.3. All right, so there is 95. So 96, somewhere like right in there. All right, and then once again, we're going to have our 45.6, so nearly 45, and so we're going to come up into there. We're going to do this right to there, right? So it's just to the side. All right, so here is the line that connects those two. And here should be what we predict to be the center. And, oh, we did a terrible job. Oh, okay, so, oh, look at how bad that is. So this is not a good use of our increments because we almost went off the damn page. Look at that. I guess we did maximize it though, didn't we? So that right there, this is our 140. Here's our not 140, 130. We're going in tens. 140, and here's our 150 over here. Okay. Wow. So this is where we're kind of predicting where our principal stresses are going to be. But also note that one of our principal stresses is going to be 0 here. So somewhere in there, just graphically, let's see. We're going to have, this is going to be one somewhere kind of over there, right? Is going to be where our big Mohr circle is going to end up with. It's just to the side. Maybe going to make it a little smaller and a little closer to the 75. How about that? Nope, that was not good. Make it a little bigger. Sure, we could just do this by the numbers, right? Oh, ever so slightly less. Yeah, I'm not going to ask you on this. That's big. Oh, look how far I went off of the thing. Oh, that was terrible. Yeah. Yeah, it's not getting any better. Okay. So this one looks like it's close to being 60, so I'm going to go like into 30 just for completeness. And I'm brave, man. I'm looking like a dummy. So I'm going to go ahead and keep going with this. I might even post this video, and you can just make fun of me. And I don't mind. I don't mind you make fun of me. Go ahead. All right, so right there, this is where C is going to be. And I'm probably going to choose this one is going to be R right there. And so right there would be one of our maximums. Here's going to be our sigma 1. Here's our sigma 2. And here's our sigma 3. Right there. And here's going to be our tau. We could call this 2, 3. And right up in here, maybe, we'll say this is going to be our tau 1, 3. But up here, as best we could say, is going to be our tau abs max. Right? So I have labeled this thing definitely. But now let's do the numbers, right? And of course, the graphics are useful, helpful, but what we really want to care about is the actual numbers. So we're not going to just measure off of the graph. We're going to actually calculate the thing. So we have negative 117.5 plus negative 96.3 divided by 2, and I say that we get a negative 106.9 megapascals, or like 107. That looks about right. 107? Sure. And then the radius of this, okay, you got to be careful here. The leg is quite small, but we're going to take, oh, I never plotted this. That would really help. 96.3 and our 45.6. Plot that point. So now, when looking at this, you know, we could draw this thing straight down if we wanted to, right? So that we can like right to there. This is going to be the leg that we're going to have to try to get. It's like the little challenge of the one. So we have, I'm just going to use the values of the thing. 106.9 minus our 96.3 squared plus 45.6 squared. Right? I didn't care about which one of these is negative there. I just want that distance that's between them. And if I do that for the radius, I get 46.82 megapascals. All right. So that's what this thing is supposed to be. So we could actually like just look right here and we say, well, it's a little bit higher than, I mean, this is where 45 is right there. So we're kind of getting off of the line right there. It's not too much higher than that. All right. And I'm out of space over here, so I'll move down below, and we're just going to keep on zooming out, aren't we? Let's say that sigma A is going to be C plus R, so that ends up being negative 106.9 plus my 46.2. So I end up getting negative 60.08. And we note that that's pretty darn close to what we got right there. And that is going to be sigma 2, right? Sigma 1 is going to be 0. And so we'll say that sigma 2 is equal to that. Sigma 3 is going to be what we often will call sigma B. C minus R, so we have a negative 106.9 and a minus 46.2, and I end up getting a negative 153.7 megapascals. And then if we have tau abs max is going to be equal to sigma 1 minus sigma 3 divided by 2, or 0 minus 153.7 divided by 2, and what we're left with is 76.86 megapascals. So when we go to give our final answer, sigma 1 is 0. Sigma 2 is equal to 60.1 megapascals compression. Sigma 3 is 154 megapascals compression, and tau abs max is going to be equal to 76.9 megapascals. And box it out. Ta-da! Now, yes, there were some challenges, and I made this just happens to be not a convenient thing. Otherwise, I basically would make it like 1/2 of this size, and not it wouldn't be very convenient to do. On regular paper, I just fudged it and just went like this right here, right? I didn't bother trying to make it to scale, and it pretty much isn't going to be to scale. But it is good to be able to do it to scale, and I would like you to have that skill set. So there you go. Mohr circle.